The next unit of concentration that we're going to explore is mole fraction, and mole fraction is denoted with the symbol X. So we can look for the mole fraction of the solute or the mole fraction of the solvent. And in either case, we're taking the moles of the part divided by the total moles of the solution. And you should note that when you add the moles of the solute with the moles of the solvent, it should total 1. So we're dealing with small numbers here. They're going to be less than 1, but not 0. And you should also note that there is no unit for mole fraction. So the mole fraction is just a number because it's a ratio of moles of the part to the total moles. Let's look at some sample problems. In this sample problem, we are asked to find the mole fraction of 50 grams of sodium hydroxide in 250 milliliters of water. So a couple things that we need to be able to do here. First of all, we need to be able to convert from grams of sodium hydroxide to moles of sodium hydroxide. So if we start with 50 grams of NaOH, how do we change that to moles? We're going to start by finding the molar mass of NaOH. So you see that there is 1 sodium, so we'll take 1 times 23. There's 1 oxygen, we'll take 1 times 16. 1 hydrogen, so we take 1 times 1. So that's the number of atoms in the formula times the atomic mass from the periodic table. And when we do that, we get a molar mass of 40 grams of sodium hydroxide per 1 mole of sodium hydroxide. So 50 divided by 40 gives me 1.25 moles of sodium hydroxide. Okay, next I need to deal with the fact that I'm given 250 milliliters of water and I need moles of water. So I'm going to recognize that the density of water is 1 gram per milliliter. So if I have 250 milliliters of water, I can use my density of 1 milliliter is equal to 1 gram to change that to mass. And once I have the mass, I'm going to use my molar mass, again, for water this time, to convert to moles. And there are 18 grams of water in 1 mole of water. So in essence, I'm taking 250 divided by 18, and I get 13.8 moles of H2O. Now that I have moles of my solute and moles of my solvent, I can calculate my mole fraction of sodium hydroxide. And notice that I add the formula of what I'm looking for down here beside X. You're going to want to make sure that you do that with your problem so that you're clearly stating if you're looking for the solute or the solvent. So I have 1.25 moles of sodium hydroxide, NaOH, and I'm going to divide that by the total moles. My total moles is made up of my 1.25 moles of NaOH plus my 13.8 moles of H2O. When I take 1.25 divided by the sum of 1.25 plus 13.8, which is 15.05, I get a mole fraction of 0.0831. And again, notice that there is no unit. All I am recording is the answer to the math. Here is another sample problem, and it's a little more complicated. What is the mole fraction of water in a 36% hydrochloric acid solution? So we need to recognize that when we're dealing with 36%, what that's really stating is that I have 36 grams of HCl per 100 grams of solution. And remember, my solution is my solute plus my solvent. So if the total mass is 100 grams and my solute is 36 grams, to find the mass of my solvent, I'm going to take the 100 grams of solution minus my 36 grams of hydrochloric acid, and I'm going to get 64 grams of water. Okay, so I need to make sure that I understand that process first. Now that I have grams of water and grams of hydrochloric acid, I can figure out my moles. So I have 36 grams of HCl times the molar mass of hydrochloric acid. Okay, so I have 1 hydrogen, 1 times 1 is 1. I have 1 chlorine, 1 times 36 is 30, or 35 is 35. When I add 35 and 1, I get 36 grams of HCl per 1 mole HCl. So this is going to be just 1 mole for my hydrochloric acid. I have 64 grams of water. I'm going to divide that by the molar mass of water, which is 18 grams. Okay, again, I had 2 hydrogens. 2 times 1 is 2. I have 1 oxygen. 1 times 16 is 16, and when I add them together, I get 18. and that's per 1 mole, which is going to give me 3.55 moles of water. Now that I have my moles, I can find my mole fraction of water. This time I'm finding my mole fraction of my solvent. So I'm going to have 3.55 moles of water divided by 3.55 plus 1. That's my moles of water plus my moles of hydrochloric acid. So when I do my division here, I end up with 0.78, and that is my mole fraction for water.